So in this problem, we're given the electrostatic force F between a positive charge big Q and a negative charge little q is just going to be minus, meaning it's attractive, it's pulling the two forces together, or the two charges together, is minus k, some constant, q over r squared, the distance between them. And we're asked to find a function u of r for the potential energy between these two charges. Now in order to do this, we have to remember that for any valid potential energy function, the udr, the derivative of the potential energy with respect to r, this distance, is just going to be minus f. So in this case, we get the udr is equal to positive k q over r squared, which means that all we have to do is take u of r is equal to minus k q over r, which has this derivative, and we have a valid potential energy function between them. Note that we could also have added any constant to this potential energy function, and this is a property of potential energy functions, is you can set them to 0 at any point that you want, and so we could have added any constant to this and it still would have had a valid derivative. So now for part B, we're asked how much work is going to be done taking a charge and moving it from a distance r naught from its opposite charge and moving it to a larger distance r. So in order to find that, we're just going to take the derivative from r naught to r of the force dr between them. And since work is path independent for conservative forces, we don't have to worry about what exactly the path is that's taken to move it from r naught to r. All we have to worry about is assume that the force is always opposing the direction of motion, so it's going to be negative the negative force. So we're going to get the integral from r naught to r of k q over r squared dr, which is just going to be minus k q over r, evaluated from r naught to r, which is just going to be k q times minus 1 over r plus 1 over r naught, or k q times 1 over r naught minus 1 over r. And this is going to be exactly the change in potential energy, the change of this function from r naught